Welcome to part 1 of 3 of my logarithm video. In this video I'm going to introduce logarithms, show you the graph, talk a little bit about how to work with logarithms as far as their simple relationships go, and then we'll go from there. Part 2 and 3 will probably focus more on the properties of logs and how to solve equations with logs. So on your screen you're looking at the graph of f of x equals log of x, and as you can see, this has, a pretty nice graph, right? There's a point here at 1, 0, which we'll get to in a little bit, and it's going to increase forever. The range is infinite and the domain is infinite over here, but it cannot be to the left of the y-axis. So what is a logarithm? First of all, the logarithm is kind of a strange thing in math that helps you deal with exponents. And the basic idea of a log is the power to which a number is raised to produce a given number. So for example, if we think about 10 squared, that's obviously 100. Well, you can actually sort of rewrite this in terms of a logarithm, and we'll get to that in a second. Similarly, if you have 5 to the third power, that's 5 times 5 times 5, and we're going to learn how to rewrite that in terms of logs. So when you think about logs, I want you to start thinking about exponents and how they are very closely related. Logs and exponents are very closely related, and we'll get more into that relationship in maybe part 2. So here we go. This is what I like to call the basic relationship of logarithms, and what we're dealing with here is called our base. So log base a of y is equal to x. That translates into, you take your base, and now your base comes out here as your big number. You take this x and you move it here to your exponent, and you set that equal to y. Now that's probably pretty confusing, but you definitely want to write that down, and we're going to go through some examples. Let's start really simple. In number 1, log base 10 of 1000 equals some number. And that number is what we're going to get by using this relationship. So watch this. I'm taking my base, I'm raising it to this exponent here that I don't know, and I'm setting that equal to 1000. So this whole thing translates into this whole thing, which is kind of interesting because now, as you can see, the connection removes the logarithm from the expression, from the equation, really. So we can work with that really easily. 10 to the what power equals 1000? Well, that answer, of course, is 3. 10 cubed is 1000. Number 2. Log base 3 of 81 equals some number. So let's rewrite this using our relationship. 3 to some number is equal to 81. So 3 times 3 times 3 times 3 is 81. So x is 4. Alright, so you can kind of rewrite this now. You can say log base 3 of 81 is 4. Now let's go to our calculators quickly. If you're using the basic TI-83 or 4, what I want you to do is hit log. And for this number 1, for example number 1, all we need to do is hit 1000 and then press enter. The reason we don't have to hit this base of 10, because 10 is the assumed base of logarithm. In other words, if you just saw log of 1000, you assume that the base is 10. So in your calculator, when you see log base 10, you don't have to actually type that in. But if you see log base 3, like we do in example 2, You have to hit 81, comma, your base. That's how that syntax works. You hit 81, comma, and then you put your base in there. So there's some calculator stuff for you. Number 3, log base 5 of 1 over 25 equals some number. So again, let's use our relationship. 5 to the x equals 1 over 25. And really the key to understanding logs, when you first learn them, is this relationship. How to get from this to this seamlessly. So let's solve it. 1 over 25 is also equal to 1 over 5 squared. Well, 1 over 5 squared is also the same as, I'll take it up here, 1 over 5 squared is also the same as 5 to the negative 2. Alright, so here we can see that 5 to what number is equal to 5 to the negative 2? Well, x has to equal negative 2. Alright, and that works every time. If you have the same base in these equations here, you just set their exponents equal to each other. Alright, how about this one? Log base 5 of 40 equals some number. Let's say that number's x, so 5 to the x equals 40. Well, the tricky part about this one is 5 to the second power is 25. 5 to the third power is 125, so this is not going to be an integer. So what I need to do is simply enter this into my calculator and get a decimal. So go back to your calculators, you hit log 40, comma, and then the base. So our answer here is 2.292. X equals 2.292. And we can check that, right? If we go 5 to the 2.292, we should get about 40. It's not perfect because I didn't, copy and paste that down, but you get the point. Number 5, now we have this thing called the ln. ln is the natural log. That's the natural log. And the base of that natural log is e. It has a base of e. Now e is one of those numbers in math that has a value. So if I go to my calculator, press second, the division sign, and I press enter, you can see that e is about 2.718. So ln can also be written as log base e of something. So these two are interchangeable. Whereas the normal base of the log is 10, the normal base of the natural log is e. Alright, so in this case, log base e of 3.3 is what we're looking for. So I can just transform ln of 3.3 to log base e of 3.3. We don't typically do that a lot. Normally we can just go right to our calculators and just hit the ln button, because our calculator has an ln button right here. So hit ln 3.3 and I get my answer, 1.194. And just to prove to you that these two are the same, hit log of 3.3 and then your base of e, and you get the same answer. Number 6. Again, if you wanted to transform this, you would say 2 to some power is equal to 2.2. Well, there's not an integer value that will give us that. It's going to be a little bit greater than 1, as you can see, but I don't really know exactly what it's going to be. So I need to go log of 2.2 comma 2. So it's 1.138. So there you go. That pretty much takes care of the basics of logarithms. Just a few quick examples there on how to sort of work with them, what logs mean, and the most important part of logs is understanding this relationship here in green. How to get from this left side to this right side. This has a log in it, this doesn't. That's your relationship. Moving from logarithm stuff to exponential stuff. That's the key to understanding this whole thing. As we move forward, we're going to, in part 2, touch on properties of logs and work with expanding and condensing them. And then in part 3, we're going to solve equations. So look forward to those. Thanks for watching.